Hey everybody, this is Larry. This is me in Asuncion. I'm in Paraguay, and this is in front of the presidential palace and a Christmas tree. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about everything. All right. Hey everybody, this is Larry. This is day 14 of the Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's farm. And we are still here in Asuncion. Hopefully I'm saying that a little bit better, here in Paraguay. As you can tell from the intro, I'm just in front of the signs. Trying to think whether I should do penguins today. Let me know in the comments how many penguins. Do you want penguins tomorrow? Let me know in the comments. I also got an early flight tomorrow, so we'll have to figure it out. But let's take a look at today's problem. We have 2147, number of ways to divide a long corridor. Along a long library corridor, there's a line of seats S and P, okay. One room divider is audience door to the left of the index. Okay, so divider at the end. There's some mod things, so let's mod. I vaguely remember this one, not that much in detail, but I just remember one edge case that I got wrong answer on because I did this on the contest. And I was really annoyed because I don't know if this part I remember, but I remember I had a really good rank, except for that I messed up on this one wrong answer, and that cost me 5 minutes, and it was probably still a good rank, but not like extraordinary or something like that. Maybe I made that up. I've done a lot of contests in the past, so I don't know. But okay. Anyway, I don't remember the actual problem though it does seem like a very obvious. It looks like a combinatorial and a combinatorial with an obvious dynamic programming type counting thing. I don't know why my eye is like. I don't know. I don't know if I'm allergic to something or something, but or maybe I just need more sleep. Allergic to not getting enough sleep. But yeah. All right. Let's actually finish reading it. Okay. So there's one on the left. There's one on the right, and you want to be able to install more room dividers. Each section has exactly 2 seats with any number of plants. Okay. Each section has 2 seats. Not for some reason I was expecting 2 plants, even though I don't know. I'm not well. Okay. So this seems pretty straightforward, I think. Right? In that, you basically have to think about what you can choose, right? Don't want to think about this up, bottoms up or top down. Man, I am so tired. Okay. Yeah. Let's do it. I think the idea is just going to be dynamic programming, right? And then now you have an index, and you just do the substring. And here you can, let me take a look at the constraint. It's 10 to the 5th, so you have to be careful. But at any given index, well, well, I mean, so sorry. Yeah, I mean, the naive way to do this is to just like have another for loop, right? But if you do this, for example, if you have a lot of plants and like, I don't know, 2 seats at the beginning and 2 seats at the end or something, then it is going to become n squared, and with n is equal to, was it 10 to the 5th? That's going to be way too slow. So we have to be a little bit careful, and I'm trying to think. What is the best way to kind of optimize that a little bit, right? Well, I mean, the 2 seats at a, so we do a division on 2 seats at a time, and then it is just going to be, I see. Actually, I think what I was thinking is kind of silly, because as soon as you split you skip to the next. You choose one of the things and then you skip to the next one, right? So then if you do it that way properly, it amortizes out to linear. Okay, so you just have to pre-compute, right? So then now maybe we write something like, basically we just keep track of the second seat and how many choices we have, right? Wait, do we? Because then now in this case, then it's just maybe we don't even have to DP, right? Maybe we could just do the what's it called? So sigma is the sum. I think a lot of people know that one, but pi is the product of a bunch of stuff. So it's just about the number of what you call it, degree of freedom, right? The number of choices we have. So we don't even need to do DP, because the idea is that every 2 seats, you have 2 seats, and then between the 2 seats there may be any number of plans. They don't change anything because you have no freedom there. But first 2 seats, then now you have a degree of freedom on all the stuff in the middle, and then 2 more seats, and then every the number of degree of freedom until the next one after that, and then that's just the pi of these things, right? So yeah, I think that's right. But you have to be careful with odd number of seats, I suppose. So we can check for that. How do we write that? If length of if corridor that count seats mod 2 is not equal to 0, then we just return 0, right? Otherwise, then now I mean, this is pretty straightforward, I think. But for C in corridor, let's see. Maybe we have current seats is equal to 0, right? Current points is equal to 0. So then now if, and then maybe counts, which is our answer is actually 1. Then now, and we know that there's at least 1 because we know that we have. Well, that's not true actually. I think if there are no seats, then there's no way to do them, right? So, yeah, so I think that's the wrong answer that I had actually. If C is not in corridor, we turn 0. Because I think for this, I actually returned 1 last time, got a wrong answer. I don't remember what year it is, so we'll see how good my memory is, or I'm just like holding on to grudges to problems randomly or something. But in any case, if C is equal to seats, then recurrent seats is equal to, we increment by 1, else current plants increment by 1, but more stuff happens, right? Okay, so the seat, okay, now there's 2 cases, right? So if current seats is equal to 2, that means that now it ended, right? So then now we can say current plants is equal to 0. Yeah, right? Else current and then now we set current seats is equal to 0. And now if seats is equal to 1, current seats is equal to 1, that means that current plants, actually I guess we should set this to like negative a billion or something, right? To start off. Something like that. I mean, okay. Because then now, if current seats is equal to 1, it means that it goes from 2 to 1, or 2 to... Yeah, no, 2 to the 1, right? Or technically 0 to 1, meaning that you have the left end, or the right endpoint and the left endpoint, and then just go. And then current points is combined into the answer, except if it's close to negative infinity, then that means that we haven't seen any seats yet, and this is the first seat that we've seen. So you can also use a boolean, I suppose. So if current points is greater than equal to 0, Then counts we multiply by current points plus 1, because basically if there are 4 seats with nothing in the middle, then you only have one choice. If you have one plant, then you have 2 choices, right? So, and so forth. So you have current points equal 1, and then make sure you mod. I think this is it, roughly, maybe. We might have to make some minor more changes, but I think this is a roughly good go. So let's give a YOLO submit. Oh, got it right this time. 20, 40, 84, not that bad. I really thought that I was going to need to do DP. Wow, last time I really did get a... Well, this isn't the last time, but the first time. And that was like 4 years ago now almost. Jeez. Jeez. Yeah, see, I forgot. I remember forgetting about this case from 4 years ago. Holds a grudge, I guess. Well, I say that, and then last time I did not remember, but this time I did. What did I do? I don't care that much about what I did last time. But yeah, let's go over, I mean, the complexity is pretty straightforward, right? This is just linear time, linear space. I guess that's it. Yeah, I mean, I think the idea is just to kind of break it down into, I mean, I really thought it would be DP just because in combinatorics most of them are, but this one is actually easier than that. But of course, you can still solve it with DP. I mean, that's how I came up with this. Because and I don't know if I made it clear because I was kind of jumping in my head a little bit. But the idea was that I was going to pre-calculate. Basically, I was going to pre-calculate for each index the next seat, right? And then I do a for loop on the cache, and I realized that the for loop is just summing it to the next index, so that you just multiply, and then when I kind of chunk it by each pairs of seats, then it's just a lot of multiplying, and that's how I came up with this one. So you could say that this is kind of dynamic programming. I mean, if you write it bottoms up, it would be probably something similar. Maybe you would pre-process some stuff so that you can quote unquote do the DP easier, but here I just kind of wrote the pre-processing them together in a way, if you want to think of it that way. I don't know. I'm passing out. That's all I have for this one though. Let me know what you think. Thanks for watching. Stay good, stay healthy to mental health. I'll see y'all later and take care. Bye bye.